So our first step is we see parentheses, so we could remove the parentheses if we wanted to, but the easier way is going to be to go through u substitution. So as we said in the last problem, if you have u to or parentheses to a number, you are going to favor that, whatever side or whatever is inside those parentheses, as your u. So here I'm going to choose u is equal to x cubed minus 3x squared. And that leaves us for our du, remember derivative, so we're dropping things. So we drop down the 3, we get 3x squared, minus drop down the 2, we get 6x dx. All right, so with that initial u and du chosen, let's see if we can successfully switch this entire integral in terms of u. So we want to switch everything to u. All right, so I kind of start off with like the most obvious thing. I start with u and I say that x cubed minus 3x squared, that is my u. So that will be u to the second power. Now if I make that replacement, I still have this x squared minus 2x, and I still have this dx. Okay, so then I go to step 2 where I focus on how do I get du to appear. So if you look at what is left over here, you have an x squared minus 2x and you have a dx. So somehow you want to get your little du to look like x squared minus 2x. And the way we can do that is by factoring out a 3. And you could factor out a 3, you could also factor out a 3x, but the thing is you want to keep this x squared inside the parentheses and you want to keep the x inside the parentheses because it is inside the parentheses for this factor. So yes, the GCF over here is 3x, but we're just going to factor out a 3 because when we do that, it will leave us with x squared minus 2x, which is inside of our integral. And then, of course, we have our very important dx term as well. And that is our new and improved du that makes it clear to us that we need to multiply in by a 3. So then we'll divide by a 3 to counteract and to balance out the integral. And then we'll have our 3, our x squared minus 2x, and our dx. So all of this is going to collapse down to du. And then we'll still have our u squared, and then our integral, and then the 1/3 is going to tag along. All right, so now we have the integral completely in terms of u. So we have successfully switched to u, and so now we are ready for the next step, which is to integrate. So we add 1 to the exponent, divide by the new exponent. The 1/3 constant coefficient tags along. For the integral part, again, that's our power rule, add 1 to the exponent, divide by the new exponent. And then because there are not bounds, we are going to add a plus c. So that gives us u to the 3rd over 9, let me scoot this up, plus c. So the integration step is done. And so now we go and we switch back to u. Back to the original variable. So let's just say switch back rather than writing all that out. So we're going to use the fact that u is equal to x cubed minus 3x squared to switch back to the original variable. So we go back up to that little key to life here that u was defined as this, and we plug in for this u the other side, the x cubed minus 3x squared. So we will have x cubed minus 3x squared. That is our replacement of u. So all of that gets replaced with u. And then we still have the 3rd power, we still have the 9, and we still have the plus c. And so that is our final answer for the integral.